Hey guys, so I've seen this problem floating around on the internet quite a bit, and I think it's actually not exactly what I have written here, but I wanted to show y'all a couple methods for solving this because it actually is a little worrisome how many people don't know the proper methods of doing this, because I see a lot of things thrown out like distribute the 4 and all this. So I just want to explain a couple different methods for doing this, show that all the different methods are the same, verify it by calculator, and hopefully put some of these arguments to rest. So, you know, I used to tutor mathematics at various levels, and one of the things I always told people to do was to, like, if they're not understanding PEMDAS, right, which is what most people do with this. And of course, if you don't know, PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. There are hidden rules in PEMDAS, so let's break that down just a little bit further before we start the actual problem. Parentheses always come first. Always, 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 unless you can't solve them. And then there are methods of solving them, which I will show you. Exponents, which is anything that looks something like 10 to the power of x. That's an exponent. You would take care of the 10 to the power of this before you'd say did 5 times. It's not 50 to the power of x, it's 10 to the power of x times 5. So then you have this guy, which I actually like to write like this. The reason for that is not a lot of people realize, but multiplication and division are actually the same mathematical operator. And I'll show you what I mean by that. They're interchangeable. You can write them both ways. So you don't actually do multiplication first always before doing division. You just do them left to right across the problem, and that comes into play later. And I will, of course, prove that with other methods. The same can be true with addition subtraction. So over here, since I've got this kind of theme going, let me show you a couple of examples of what I mean by that. Let's say I have 5 times 10, right? And this is 50. Sure, let's say I have 5 divided by 10. Or let's do an easier one, right? Let's do 10 divided by 5. Now, you know that this is 2. One thing you may or may not see is that this is the same thing as saying 10 times 1 over 5. You can actually go backwards on your math and make some of these easier. For example, and this is what Common Core forces you to learn. You don't actually need to know this, but it is a good method to know, I think. You can say that 10 is equal to 5 times 2 times your original 1 over 5, and now you can see these 5's cancel. You get 2. So 10 over 5 is equal to 10 times 1/5. Those are the same. It may be, obviously fractions are cheating a little bit because they are division problems in and of themselves, but you can treat that as a variable. You could say that 1/5 is a. So you have 10 times a. Whatever a is fine. A can be a fraction, and then you do your division, and a could be a whole number, right? The same can be said with addition subtraction. So if I have, for example, 10 minus 5, we know that's 5. That's also the same thing as saying 10 plus negative 5. These are the same operator. 10 minus 5 is equal to 10 plus negative 5. This, I don't blame you if you skipped all this. This may seem really basic, like very, very basic mathematics, but you'd be surprised how many people forget these operations when trying to solve, you know, one of these IQ test online problems like this. Which, full disclaimer, I am not a fan of these. These are simply set up to, they're not a good IQ test. They're not set up to see how well you can problem solve. They're set up to see how well you memorize stuff in middle school or high school or whenever you learn this kind of stuff. So let's do the actual problem. So the problem looked something like 8 divided by 4, quantity 2 plus 2. Now the first thing I tell students when I'm tutoring them and they're having trouble with this kind of thing is, you know, we have an implied operator here. That's a multiplication. It's implied. It's not written out, but it is implied that that is a multiplication step. So what I say is, if you're having trouble with these kind of problems, get rid of the assumed operators. Make them a non-assumed operator. So we have 8 divided by 4 times 2 plus 2. So far, so good. The next thing I would recommend everyone do is get rid of multiplication. Now, what do I mean, or not multiplication, division. Now, what do I mean by that? Remember when I said these two are the same operator, and I showed examples of that over here? Well, we can do this right here. That this is equivalent of 8 times 1/4 times 2 plus 2. Now this problem looks very, very straightforward, doesn't it? We do our 2 plus 2, which is 4. We get 8 times 1/4 times 4 equals, and these will cancel, and this is just 8. Now, I know a few people are already upset because I've seen, like I said, I've seen this floating around the internet, and what a lot of people say is, you know, you have to do the multiplication before the division. You can't just do what I did, right? So let's show it a different method. Let's actually do a distributive property. So distributive property says, I'm going to rewrite this as our multiplication again, because that would be the next step anyways. So that's 8 times 1/4, which is the same as 8 divided by 4. Or let's not do that just yet. Let's write the original problem. So here's our original problem. We can actually use something called the distributive property. Now, the distributive property doesn't really help much with these problems. Any good mathematician will tell you to use this method instead of what I'm about to show you. What you really use distributive property for is if you can't solve the quantity, right? So if this were x plus y, you can't just add those together, right? That's x plus y equals x plus y. You don't know what x is, you don't know what y is, so you would distribute. But we can actually use that with regular numbers. They are equivalent. That method checks. So let's rewrite this once more as our multiplication step. So 8 times 1/4 times 2 plus 2. Now, since these are both multiplied, we can use distributive property. Which again, distributive property says something like if you had x plus y quantity, and then you had twice that. Well, this is equivalent to 2x plus 2y quantity. You can just distribute like that. So let's go ahead and do this step, but for our original problem. So we have 1/4 times 2, which is 2/4, plus 1/4 times 2 is 2/4, quantity times 8. Now what you'll notice, and this is what was kind of interesting to me when I watched people do this online, is they would immediately stop and just say, you know, that's the distributive property. Well, the distributive property works with anything times anything. You can actually, you have to, if you're going to solve this, you either have to solve the quantity here and multiply it. We'll do it both ways. Let's do that first. So we have 8 times, this is 1/2 plus 1/2, which is just 1, which is 8. And look, that's what we had before. There's the other way of solving this, which is we distribute the 8 across. So then we have 16/4 plus 16/4 quantity, which is 4, right? 4 plus 4, which is 8. And look at that. Now, this may seem redundant, but again, I'm a firm believer that the more times you can show the same answer by doing different methods, the more correct that answer is. So, for example, if we were to have other people, like I've seen online, arguing the other way. A lot of people online only have one way of solving what they're going for, and, you know, frankly speaking, it's incorrect. And I don't mean that in a harsh, negatory way, but it's just not correct. And so the way I could disprove that is by just simply showing, here's 3 different methods we've done so far that give us 8. And they can only show 1. which means that there are more ways of getting the right answer than getting the wrong one, right? That's a mistake. That's what we call a mistake. And understanding the mistake is crucial to understanding why your method doesn't work, but it is a mistake. Now, the last thing I want to show you, this is my beautiful FX 115 ES Plus. This thing is my problem solver, baby. This does it all. Let's type that original problem in. We have 8 divided by 4 times, in parentheses, 2 plus 2. And that gives us 8. Now, if you don't trust me and you don't trust what I did, and you don't like any of this, at this point, you can have that debate if you want, but I just showed you on a calculator that it works that way, which means someone who programmed this computer right here to do PEMDAS, which is what they do, also agrees with this answer. If anyone has a specific problem like this they want to see solved, I would be happy to show how it's supposed to be solved. But the stuff where, you know, again, I've seen a lot online where people take this original problem and they just go, well, you do the parentheses, so this would be 2 plus 2 is 4, and then you do 4 times 4, which is 16, and then 8 divided by 16, which is 1/2. I'm sorry, but that is just incorrect, as proven 3 times here, as well as a calculator. So anyways, I hope you found that interesting. I hope you found it entertaining, instructful, whatever, useful. Don't beat yourself up if you didn't get it right the first time. Like, again, this isn't an IQ test. IQ is supposed to prove how good you are at solving problems, and this does not test that. This tests how good is your specific knowledge of PEMDAS and mathematical operations. And, you know, it's fair that not a lot of people do this math a lot. So don't beat yourself up, but don't go around on the internet calling people idiots for getting it right either. You know, there's a balance to be had there. Anyways, y'all take it easy, and again, if you have any problems you've specifically seen online you would like to see solved, hit me up. I'd be happy to do it. Y'all take it easy. Bye.